Hi guys, today we're talking about rewriting equations and formulas. So to start off, we're going to go over a couple vocabulary terms. A literal equation is an equation with two or more variables. So an example of that would be 3y minus x equals 5. Because in this equation, we've got two variables. We have the y and we have the x. A formula is just a type of literal equation that shows how one variable is related to one or more other variables. So some common formulas that you've probably used before, area equals length times width. This is to find area of a parallelogram. Distance equals rate times time. Or our simple interest formula to find interest, we do our principal times the rate times time. So just some common ones that you guys have probably seen or used before. So let's first talk about rewriting equations. So sometimes for various reasons, we want to rewrite an equation in terms of another variable. So in this first equation, they're asking us here to solve for y. So we start with the equation 3y plus 4x equals 9. But we want to solve for y. So we want y to be isolated by itself. So the first thing I'm going to do is get rid of the term 4x by subtracting it from both sides here. So I'll be left with 3y equals 9 minus 4x. It's okay that this got a little more complex. I'm trying to get y by itself. So now I'm going to divide both sides by 3. So in this case, the 3's will cancel out. On this side, I can do 9 divided by 3, and I get 3. 4 divided by 3 is going to work, but we're going to get a repeating decimal. So I'm just going to leave it in improper fraction form, minus 4/3 x. So y equals 3 minus 4/3 x. Here's another example. This time, we're doing the opposite. We're being asked to solve for x. So we're trying to isolate the variable of x. So I see in this one, I'm starting off with y equals 3x plus 5xz. So x is in both of the terms on the right side of the equation. So I can do factoring, which is the opposite of using my distributive property. I'm actually taking an x out of both of these terms. So it's going to leave me with, in parentheses there, 3 plus 5z. And you can imagine if you were going to distribute that x would go to the 3, x would go to the term 5z, and we'd be back with what we started with. So we're just kind of taking that x out. So now we've got y equals x times 3 plus 5z. So I'm going to divide each side by the quantity 3 plus 5z. So the 3 plus 5z over there will cancel out, and I'll be left with y divided by 3 plus 5z equals x. So in this case, I have solved for x. X is now by itself. So let's try this with a formula. So here's a common formula you've probably seen before. Degrees Celsius equals 5/9 times the quantity degrees Fahrenheit minus 32. Well, what if I wanted to have this solved for f? Okay, I want f by itself. The first thing I'm going to do is get rid of this 5/9. So anytime I'm trying to get rid of a fraction that's being multiplied, I can always divide by 5/9. Or an even quicker thing I could do is multiply both sides by the reciprocal of this fraction. Because when you're dividing, you're just multiplying by the reciprocal as a shortcut. So I'm going to multiply both sides by 9/5. And I'm going to end up with 9/5 times my degrees Celsius equals f minus 32. Okay, now to get rid of this minus 32, I'm going to add 32 to each side. And I get 9/5 times my degrees Celsius plus 32 equals my degrees Fahrenheit. So now, if I have something in Celsius and I want it in Fahrenheit, this will be an easier formula to use. So let's actually try it out. So if we have a problem like this, Mercury has a surface temperature of 427 degrees Celsius, and Venus has a surface temperature of 864 degrees Fahrenheit. Which has the greatest surface temperature? To compare these two, I'm going to have to actually change the temperature of Mercury, the 427 degrees Celsius, into Fahrenheit. So that way, if they're in the same unit, I can see which one is having the greater surface temperature. So I'm going to use this formula that I just came up with in Fahrenheit to solve this guy. So I'm going to take that 427 degrees Celsius and substitute it in here for C. So 9/5 times 427 plus 32 is going to give me my degrees Fahrenheit. So 9/5, or 1.8 times 427 is going to give me 768.6. Now I have to add 32 to get my degrees Fahrenheit. And 768.6 plus 32, I'm going to be at 800.6 degrees Fahrenheit for the temperature at the surface of Mercury. So if I compare this to Venus, Venus actually has the greatest surface temperature. So for my answer here, it's Venus with the greater surface temperature. So hope you guys found this a little bit more interesting than my dog Fox, who has slept through this entire lesson. Let's see if we can catch him. There he is sleeping. Hi, Fox.